Hello again. Let's discuss statistics and reliability. There are several different methods for phylogenetic construction in the toolbox. Largely, they are classified as two groups. One group is distance-based, including UPG-MA and NJ. The other group is character-based, including MP, ML, and BI. In this section, I will explain the basic logic behind each method. For distance-based method, the first step is to calculate pairwise distances between sequences, and the resulting distance matrix is the only information used in later analyses. In other words, information reduction might occur during data transformation. One simple distance-based method is UPG-MA, i.e. underweighted pair group method with arithmetic mean algorithm. This method constructs a tree by identifying the shortest distance in the matrix, clustering those two taxa into a single OTU, and calculate a new distance matrix, and then repeat these steps. For example, here the shortest distance is 2 between A and B, so we cluster A and B into a new OTU named AB. Then clustering D and E, AB and C. Let us continue this process. Cluster ABC and DE, and finally ABC, DE and F. The root could be determined by additional information, for example, outgroup. Another distance-based method is neighbor joining algorithm. This method is different from UPG-MA in that it allows for unequal rates of evolution in different branches of the tree. If the distance matrix is accurate, NJ will always infer the true tree. The NJ algorithm is a divisive cluster algorithm. It starts from a star tree. Two nodes are then joined together on this tree. In this example, nodes 1 and 2, reducing the number of nodes at the root, node X, by 1. In this example, we first cluster A and B, resulting U1, and then cluster D and E, resulting U2. The process is repeated until a fully resolved tree is generated. Maximum parsimony is a character-based method. That is, it utilizes the information of the original sequences instead of the distance matrix. The philosophy basis is the famous Occam's razor principle. For example, why did the tree fall? One explanation is that the wind knocked down the tree. The other explanation is that two meteorites hit the tree and knocked it down. Which one is better? The simpler one. It has higher probability. Here is an example. We have 5 DNA sequences and propose 2 hypothesized trees. Let us examine which one is better according to the first character. This column with a red box, we can set the ancestor state as different scenarios and to examine how many mutations are needed to reach the proposed tree. Scenario 1, 1 mutation. Scenario 2 and 3, 2 mutations. Scenario 3, 3 mutations. As mutation is a rare event, we will choose the simpler scenario. In this case, the first one. This is the basic logic underlying maximum parsimony. Another character-based method is maximum likelihood. Likelihood is a statistical concept. In brief, likelihood measures the goodness of fit of model to the observed data for given values of the unknown parameters. In phylogenetic analysis, the data are the sequences. The model with different parameters are the phylogenetic trees with various topology. Likelihood provides probabilities of the sequences given a certain tree. So, maximum likelihood method identifies the tree that most likely produced the observed data. Here is an example. We have 4 sequences with 7 characters. These different trees are proposed as competitive hypotheses. Given the observed data, which of the 3 models can produce maximum likelihood? Here we take the third column as an example. For model 1, the likelihood is calculated as the sum of 16 terms. It is somewhat complicated. Here we do not want to deal with the mathematical details, Just remember we can calculate the likelihood for each model. Using the similar procedure, we can calculate the likelihood of all three models for all sites and then add them up. Now, the model with the maximum likelihood is preferred. In summary, we have several different tools in our toolbox for phylogenetic construction. Each method has its advantages and disadvantages. In some cases, for the same set of data, you may get different results using different methods. What can we do? We will discuss how to assess the quality of phylogenetic trees. Phylogenetic trees represent historical evolutionary patterns, which are often unknown. Ergo, it is not easy to assess their validity and reliability. Validity means the tree is an accurate measure of the true history. Reliability means the tree is robust across different repetitive measurements. In phylogenetic analysis, if you can get consistent results across independent methods and markets, you will have more confidence. Bootstrap analysis is widely used in assessing the reliability of different phylogenetic trees. Bootstrap is a looped strap sewed at the side or the rear top of a boot to help in pulling it on. A famous proverb is, "Pull oneself up by one's bootstraps." Of course, your physical teacher will never agree on this idea. Well, in statistical analysis, bootstrap is just a metaphor. In statistical analysis, we usually infer the population parameters by repeated sampling from the target population. However, in some cases, we have only one set of sample data. Bootstrap sampling method allows to calculate the parameters by producing some pseudo-samples. As these samples are from the original sample, it is just like pull oneself up by one's bootstraps. Here is an example. We have an original sample of 4 sequences with 7 sites. Here, each site can be treated as a sampling unit. Here is the first bootstrap example. There are 7 sites, but some sites are repeatedly sampled from the original sample. Repeat this procedure for many times, usually 1,000 times. You can calculate a bootstrap value, which is an indicator for the reliability of your result. In phylogenetic analysis, you can calculate a bootstrap value for each node. It is a number equal or less than 100, meaning the percentage of times a cluster reappears in the bootstrap replications. For clusters with a bootstrap value of over 95 are widely considered to be exceptionally reliable. Usually a bootstrap value below 70 is considered unacceptable. I hope you've enjoyed this lecture. Bye for now.